I'm going to move on to our next speaker. Our next speaker is Ernesto Hernandez, and he's going to be speaking with us about applications of new short path stripping technology and edible oil processing. Ernesto has quite the bios. He is currently the principal consultant with Advanced Lipid Consultants in Tomball, Texas. He is served on the faculty at Texas A&M as the former head of the Fats and Oils program. He's worked in the graduate food science as a member of the graduate food science faculty at Texas A&M. He has co-authored 2 books, holds 2 patents on specialty lipids and process design, and he has published over 100 articles in several areas of lipid and food product development. Obviously, Ernesto has quite a bit of experience in the area of processing and development of fats, lipids into food products. Please welcome Ernesto Hernandez, our next speaker.
Hello, everyone. Welcome to the presentation, Applications of New Short Path Stripping Technology in Edible Oil Processing, by myself, Ernesto Hernandez, from Advanced Lipid Consultants, and Perry Alasti from Artisan Industries. This presentation will include a quick introduction on the general aspects of edible oil processing. Then we will talk into more detail on Artisan's multistage short path stripping technology compared to the single stage short path distillation processing. Then we'll go into applications of this new Artisan technology in edible oil physical refining, removal of contaminants, and also on the concentration of omega-3 fatty acids. Edible oils are generally processed to remove impurities and contaminants to meet regulatory and quality control standards. Components and impurities normally removed include free fatty acids, phospholipids, color components, peroxides, carboxylic compounds, and other environmental contaminants. Most edible oils undergo 4 basic processing steps: refining or neutralization, bleaching, winterization, and deodorization or physical refining. The last step is usually used to remove odors or flavors, and in the case of physical refining, to remove free fatty acids and other environmental contaminants. And it is in this last step where short path distillation has a great deal of potential. This slide shows the difference of processing of the 2 major edible oils globally, which is soybean oil and palm oil. Soybean oil is normally refined using caustic or sodium hydroxide solutions to neutralize the free fatty acids, and palm oil uses physical refining to remove free fatty acids by distillation. Oils like palm oil, palm kernel, and coconut are usually refined by physical refining, which basically means removing the free fatty acids in the deodorizer. This is due to the fact that the free fatty acid content of these oils is relatively high and is more economical to remove the free fatty acids by distillation. Oils like soybean, canola, sunflower, corn, on the other hand, have a lower content of free fatty acids, and they can be more economically refined using caustic refining. The difference between these 2, chemical and physical refining, is that chemical refining is carried out, the deodorizing part, at lower temperatures and also lower residence time. In physical refining, the deodorization takes place at higher temperature and higher residence time. As a result, there is the disadvantage of generating some process-derived contaminants such as GEs and MCPDs, and also the cost can be higher. Later on, we will see how the new Artisan evaporation technology will be able to mitigate these contaminants and also to use this technology as a physical refining method. Another issue with edible oils, especially oils like fish oils, is the presence of persistent organic pollutants, such as dioxins, furans, PCBs, pesticides, and brominated flame retardants. And in many cases, these oils have to be processed by molecular distillation in order to meet regulatory standards. Besides environmental pollutants, we also have process-derived contaminants in edible oils, such as trans fatty acids, polymer, cyclic compounds, MCPDs, and GEs. More recently, process-generated contaminants such as MCPDs and GEs in some refined oils have become a concern. For example, in palm oil, which has some of the highest content of diacylglycerides, and the use of high temperatures and long residence times tend to generate these contaminants, MCPDs and GEs. MCPDs and GEs can be genotoxic and or carcinogenic. And as a result, regulatory agencies in North America, Europe, and Asia have set up strict limits for the presence of these contaminants in edible oils and many foods. As a result, the industry has started to implement several methods to remove or mitigate the presence of MCPDs and GEs. Some measures include bleaching or post-bleaching and also post-deodorization. And more recently, some processes have been successfully introduced that use short-path distillation. An area where short-path distillation is commonly used is in the production of omega-3 ethyl ester concentrates for pharmaceutical and supplement applications. Basically, fish oil or other omega-3 oils like microalgae oils are transesterified with ethanol using a catalyst to produce these ethyl esters of the fatty acids of the fish oil or other marine oils. Once the ethyl esters are produced, then they are subjected to short-path distillation, where the shorter chain ethyl esters are distilled off and the EPA and DHA ethyl esters are concentrated. However, there is a limitation. In general, the short-path distillation will be able to concentrate only up to 50% EPA and DHA. As a result, other technologies have to be used to further concentrate these omega-3s to achieve the supplement and pharmaceutical requirements. For example, the use of urea crystallization that can concentrate further EPA and DHA up to 84%. Later on, we will see that the new Artisan multistage evaporation technology is able to replace the conventional short-path distillation and be able to achieve much higher concentration of EPA and DHA. This slide shows the difference between thin film evaporation and short-path distillation. In thin film evaporation, the vapor generated from the falling film travels into the vacuum system, whereas in short-path distillation, the vapor generated from the film travels a short distance into a condenser. Molecular distillation normally refers to the use of an apparatus where the gap between the evaporating surface and the condenser is equal or less to one mean free path of the molecules evaporated, thus facilitating collision-free transport, as illustrated in the equation below, where the free path is generally estimated from the vapor pressure, the molar mass, the gas constant, and the temperature. Short-path distillation generally operates at very short residence times, high vacuums, and the distance between the evaporation and the condenser is very short. As a result, we have very efficient mass and heat transfer, and the condensation of the vapor generated into the internal condenser is very quick. Common configuration includes thin film generated using devices such as rollers and wipers, fixed clearance blades or pitch blades rotated inside the column to spread out the film. Artisan Industries offers a new thin film, falling film evaporator equipped to overcome the problems associated with film distribution in falling film evaporators. In the standard design, the feed introduced at the top of the unit cascades down as a thin film through a series of tube and disc trays, where the volatile components are stripped into the vacuum system or condensed in an internal condenser for more efficient recovery of the condensate as a product. Evaporation takes place through several stages, where each tube and disc tray creates a fresh liquid film at each stage, providing a new surface for evaporation and condensing. The basic design has semi-cone solid distribution discs for moderate vacuum applications. The system is also designed to operate at high vacuums. This diagram shows two options of the new Artisan multi-stage thin film evaporation technology. In the first option, we have a system where the vapors generated travel out of the evaporator into the vacuum system through the size or the chimney in the evaporator. In the second option, we are introducing an internal condenser. So in this case, the vapors generated do not travel into the vacuum system, but instead they are condensed on the internal condenser and fall out of the evaporator as a product, as a true short path distillation technology. The first application to be reported is the use of Artisan multi-stage short path distillation technology to physically refine palm oil, and we successfully removed the free fatty acids and refined the palm oil to meet commercial standards with, for example, reducing the free fatty acids from almost 4% to less than 0.1%, also reducing the peroxide value. And as we can see, the triglycerides also increase because the short path distillation multi-stage evaporator also removes monoglycerides and diglycerides. And as a beside point, we also notice that the removal of tocotrienols is minimal, and this would involve some optimization trials according to the customer's needs. The Artisan multi-stage short path evaporator was also tested to mitigate the content of MCPDs and GEs in palm oil. And as is shown in the slide, the Artisan's short path evaporator was capable of reducing glycidyl esters and CPDs to within regulatory standards. The Artisan multi-stage evaporation technology was successfully used in the concentration of omega-3s, specifically omega-3 ethyl esters of EPA and DHA. Normally, systems of molecular distillation can concentrate only up to 50% EPA and DHA. As a result, other technologies such as urea crystallization have to be used. The Artisan multi-stage evaporation system is capable of concentrating above 50% EPA and DHA for supplements and pharmaceutical applications. This system also is successfully applied in other oils such as flaxseed and microalgae oils, without destroying the nutrients, such as EPA and DHA. 100% of the omega-3 fatty acids are preserved, and as an added advantage, as mentioned before, the multistage Artisan evaporation system is used to remove glycerol esters and MCPDs that are also found in some marine oils. The new Artisan multistage thin film evaporation technology has been successfully applied in several other applications. So far, we have covered the use of this technology in the physical refining of edible oils, also in the removal of environmental and process-generated contaminants such as PCBs, dioxins, GEs, and MCPDs, and more recently on the concentration of omega-3 fatty acid ethyl esters that are now widely consumed in some supplement and pharmaceutical applications. Other applications of this multi-stage thin film technology is in the concentration of mono and diglycerides that are widely used as emulsifiers, the removal of other contaminants from oils like citrus oils, also in the recovery or removal of cholesterol from animal fats, the purification of essential oils, and also the recovery, which is not listed here, of antioxidants, and more recently, the recovery of squalene from shark liver oil, olive oil, and amaranth oils. The Artisan multi-stage thin evaporation technology offers several important advantages over commercial deodorizers and molecular distillation systems. The Artisan evaporator operates at lower temperatures and lower residence times. Therefore, there is no generation of process-generated contaminants, and also no deterioration of the nutrients of the edible oils, such as omega-3 fatty acids. Compared with molecular distillation systems, the Artisan multi-stage evaporator has the added advantage that it has no internal moving parts, and also it is a true multi-stage evaporation system. And the Artisan evaporator has the added advantage of having an internal condenser that allows us to recover the condensate as a product through the internal condensation system. This allows for a more efficient heat and mass transfer and avoids having to use multiple units, as is the case of conventional molecular distillation, where multiple systems have to be used in order to achieve the required concentration levels or required purity of the product to meet regulatory standards. We are estimating that this innovative design by Artisan for a short path system allows for more than 50% savings in capital expense, operation and maintenance costs in most deodorizing and distillation operations.
Hi, Ernesto. Thank you for that presentation. We have a quick time for a quick question, I hope. We had one question here. It said, would this technology be able to achieve GE less than 0.05 parts per million?
Yes. Just think of this technology as, in fact, we believe we can replace many of the processing capabilities of normal molecular distillation. So we have been able to process palm oil, for example, which lately has been found to have higher amounts of these processing contaminants to within regulatory limits. It's just a matter of the starting content of the content of these contaminants in the starting material. You can adjust residence times, you can adjust temperatures, you can adjust feeding rates and that sort of thing. So that's the advantage of this system. It's very versatile. You can modify, for example, the number of theoretical plates inside the system. So it's very versatile, very innovative.
Yep, that's very good. We have time for one more question here, and I'm going to try to pick one that's going to be a quick one. It says, what would be a typical pressure drop through the stripping column?
That is a great question. And that is the advantage. And again, having such a versatile system, you can choose between having an internal condenser, which means the vapors produced or generated are almost immediately condensed. So your pressure drop is minimal. Now, if you choose not to have an internal condenser and instead have the vapors being exhausted into the vacuum system, then of course your pressure drop will increase, because of the vapors having to travel such a distance and the vacuum system having to work to evacuate this vapor. So the pressure drop will increase there. But you have the choice of having an internal condenser where you minimize the pressure drop, and it actually allows you to have very high vacuums, just like in conventional molecular distillation.
I think that might be all the time we have for questions at this point. We have some more questions, and I would remind the audience that we will be having a Q&A session after our next speaker, Christopher Clark. So please stay tuned. We want to get to your questions and make sure that they get answered. And Ernesto, thank you very much for sharing this information and talking about this new technology.